Can you answer to the warm-up recap question? One. Hello, if you just joined, we are still on the recap questions from last week. So if you have any answer to this recap question, feel free to type your answers in the chat before we move on to other topics today. Anyone? Make your best educated guess, if possible. Okay, we have one answer. Does everyone agree it's B? If you agree the answer is B, then type a +1. People disagree the answer is B or agree. B, okay, seems like we have a consensus. So yes, B will be the right answer. So we'll fill in the missing value here. And okay, kind of a follow-up question. Can anyone tell me what will options, if I execute option C, what will my DF become? Can anyone tell me that? If I execute option C, what will I get? Kind of a follow-up question. This is a common pitfall people make all the time.
I think it will replace the null value of column B with the average of column A.
Let's see. You think it's going to also fill the missing value in column B with with the average value in column A, right?
Yes.
Okay, let's see. Well, it's actually not. It's actually true. DF the field NA, and yeah. So this is another example of showing how to do like. You have to be careful when you're calling this function. This particular function is going to assign this new data frame with whatever value that's here. On the other hand, in some other cases in pandas, this is a feature I don't like. If you do like, let's say in place is equal to true, you might get an error or you get a none. Why? Because now this is becoming a method. It does not have any return value at all. So be careful with this type of operation. You might fill something that you don't want to fill, or you might end up getting a completely null data frame at the end. Okay. All right. So this is just a recap of what we have seen before. We have basic fill in A. You can specify the missing value, like how would you fill in those values by columns. You could also do them in place. You could have the return value, or you could just fill in whatever value you want, or you could do forward filling or backward filling. And similarly, you have the like drop duplicate function, which is even simpler. You're basically just dropping the row with this identical content. You might say, okay, why would that ever be a problem? Well, in some database I've seen like maybe 20% of the data are exactly the same. What might that be a problem? Well, if you're interested in the average value of the entire population, or for whatever reason you're interested in mean value or the median value, then if 20% of your data set is repetitive, your data is trash, basically. If you're 20% of your data set or even 10% of your data set is repetitive, your data is basically trash. Okay? And this thing I shouldn't click on that. Anyway, and we also have some other common operations in basically a type will convert your data type from one of them into the other. And we have int, float. There are a couple different types. You can convert it into int 64, int 8. If you are sacrificing some of the precision, sorry, float 64 or float 32 or sometimes float 8, you can sacrifice part of the precision for your memory. And I think this is probably not a problem that we're going to see in Python 100, because most of the time we're not going to give you a large data set. It's going to overload your computer. But this type of operation is meaningful because it will change the like accuracy of your predictions or whatever you're doing. For the for those of you who are trying to experiment with OpenAI models, this is how they do like quantization. You may see, oh, there's Gemini 2.5 billion, and there's quantization for 8 bits or 64 bits. Why does that matter? Well, that's because they are truncating some of the float numbers to make their models smaller. That would sacrifice your performance, but that would make their models more portable so that they can run models on your phone instead of on a computer. But that's a different story. And there are common datetime function that will convert that into many different formats. These are just basic syntax. I think these are a little bit more self-explanatory. So we're just going to brush through them very quick. So the main thing unless you guys have any specific questions, either from homework or from the materials. Otherwise, we're going into the main thing for today, which is regex pattern matching. So a little bit more about, this is copied from the class page. I think this is a great introductory materials. So regex pattern matching is not unique to pandas or Python. It is actually like a much broader like package available in multiple different languages. You could do it in JavaScript, in SQL, in C, C++, R, MATLAB, or whatever language. Like most of the common programming language, you should be able to find like the application or packages for regex. So regex is a tool for matching strings, and it dated way before we have all the large language model or like natural language processing method. It is basically telling the computer, okay, to match this specific pattern and return all of the pattern that matches that. It is extremely performant, to be honest. It is really a fast algorithm. On the other hand, it's a really painful thing to write, in my personal experience. My personal suggestion is, if you can find something that's already written, like there's a website. I think if you go to regex how to, I don't have the tutorials page, but if you go to the regex how to, there's a website collecting, okay, if you want to collect emails, this is the regex pattern for that. If you want to collect phone number, this is the regex pattern for that. A lot of those have existing regex pattern. I would actually start by understanding how those work. But anyway, there are a couple patterns. So Actually, let me go to this CTD thing. I think the rendering on my Colab notebook is a little bit off. Ouch. It's not going to let me log in on this. Okay. Hold on a second. Let me share different stuff. Okay. So here we have the basic introduction to regex. So this is just telling regex if you either start with R this or this, you're going to start the regex pattern. It doesn't really matter. The real key here is this pattern star and all this thing. We're not expecting you to memorize all these things, and this list is not exhaustive. There are a couple other regex like patterns existing. This list is not exhaustive. I think it makes a little bit more sense in my perspective to explain them with real example instead of just going through all of this and telling you, okay, how does that work out? So that's what we're going to do today. So today we're going to see some basic regex example and also finish Tom's like the regex challenge by Tom. And hopefully we can go through that. This is the right. No, this is not the right tab. Hold on a second. Hold on. Where's my collab? Okay. No. Hold on. I have too many tabs open at the moment. Where's the right tab? Where's the right tab? I think this is the one. Yes. Why am I not allowed to move? I think something is wrong with my laptop, but okay. There's just laggy. So let's start with a quick demo. Data frame. We have this weird, messy data frame we just created. If you run it, it will just look like this. So our first goal is to clean up the phone number. That's actually the easier task here. How can we do that? So we can first do that by we're changing all of the data type to a string. Well, hypothetically, you could skip that, but it will depend on the version of Python and the version of pandas you have. If you do not convert it into a string, some older version of pandas may just turn this non-string into an NAN, just so you know. So if you're ever going to use a regex pattern matching, the recommended approach is to convert it into a string. So now once we're into a string, the /d will tell it to basically replace like all of the string that's not a digit into a empty space, which means that, okay, up to this point, the regex pattern is going to do, okay, search through each of the string here. And okay, this is not a digit. What do? We're going to eliminate that. So we don't have a dash, we don't have a dash. And here for this third entry, we're going to eliminate the parenthesis and the dash and the empty space. Okay? And once we finish this pattern matching, this replace, we're going to replace all the empty string. For example, this NA, because it's not a digit at all, will become completely empty. So it will be replaced by np.nan. And that's exactly what we got. Now, let's see. We have another one. This one, oh, I think I eliminated errors by well, I think I didn't eliminate the error. Yes, I didn't. I fixed the error myself. But anyway, Let's try to break down this regex pattern. So this symbol is going to tell it, okay, this symbol is interesting because when it is at the beginning, it tells the regex pattern, okay, the next pattern has to be in the beginning. On the other hand, if I type it here inside a pattern, that means, okay, it couldn't be an A to Z. It shouldn't be A to Z, 0 to 9, and a dot. This is either a not or telling the pattern, telling regex this is the beginning of the pattern. And let's see. Now this plus sign will tell the regex, okay, this previous pattern will only be matched once. So similarly, if I type D plus, and well, this is going to tell it it's going to once. It's not going to. Oh, sorry. This is going to do the recursive task. Well, never mind. This is not the right way to do it. This plus sign will tell it to match this pattern exactly once. And this at sign is going to say, okay, this is just an at. And there are special characters you need to escape. For example, like all of the characters here, if you want to match, okay, what if I want this pattern to contain a dollar sign? Well, you will need to type /$ dollar to include the dollar sign here. And let's see. If I change this, I believe this will give me an empty string because I'm telling it, okay, my email shouldn't start with A to Z and 0 to 9. Let's see if I can change it from B to Z. I think this will left out the bubble. Wait, no. No. Let's see. It shouldn't contain A to Z. C plus C. Because it also contains 0 to 9 and dots. Anyway, I'm not a person with perfect regex skill. This sign, when it's typed inside a pattern, will become a not operator. And it's more or less a complex operation because it's kind of anti-human to understand that. This pattern will tell you, okay, it's A to Z, capital letter. It's not A to Z, capital letter. It's not A to Z, lower case. It's not 0 to 9, lowercase. Things, if I do it this way, you'll get the same thing. If I do it this way, I think there's a way. This is still assigning. Oh, no, because this is going to tell it it's going to have a substring. No. Yes. And the second one here is telling it, okay, it could be we're matching a pattern of A to Z, basically all the alphanumeric one, plus a dot or a dash once, and then match that with a dot, and then match that with another string, alphanumeric string. So this one is specifying alphanumeric string or a dot once, alphanumeric string or a dot once, plus an X sign, and then alphanumeric string, plus a dot or a dash, and then plus a dot and alphanumeric string. So my final thing should be something at something dot something. And I believe if I eliminate this, I'll get more entries because I'm not specifying that to have a dot here anymore. This is a standard way. This is, well, I wouldn't say this is a standard way because there's more than one way to pattern match the email like this. There's more than one way to write the same regex pattern. And usually, this is not something I would be happily writing myself, to be honest. If you could find a pattern for email or find a pattern for something that you think should exist, try to go with the whatever you can find online. Do not try to write this yourself. Most of the time, you will fail the regex pattern matching. But anyway, let's still try to finish this challenge by Tom. So let's start with the first one. There are a couple other things that in this quiz that's created by Tom, but that's not included in the material. We'll go through that anyway. So first, this sign is telling it to match at the beginning, and this dollar sign at the end is not telling it to match any dollar sign. Remember, if you want to match a dollar sign, you need to do a slash. So this actually, if you go to the reference page, you'll see, okay, this is telling the pattern to match to the end. Okay, beginning to the end, and the end for this pattern. What does that even mean? That means the entire string needs to follow this 0 to 9 pattern exactly once. So, which of them is the answer? A, B, C, or D? This telling us this dollar's beginning, well, this XOR and this dollar sign is telling us the entire string need to follow this pattern. And this pattern is any number in any number of combination. Which of them is the answer? D. I agree. Okay, now let's see the second one. Again, the entire string need to follow the pattern in between. Okay, and the question mark is telling us, okay, this could be either matched once or 0 times. And let's see, slash D5. Can anyone tell me what this slash D5 has to match? Slash D5. Anyone? Should I randomly? Okay, I see one answer. So this slash D5 actually tells us we need to match a digit, like any number, for 5 times. So we need to match a number for 5 times, and there's a second pattern. So let's see which one starts with a number for 5 times. This, and this, right? And the second one doesn't work because it has a dot, but we want 5 consecutive number. That's what this slash D5 is telling us. Now, the second thing is here is, okay, we could have a dash or colon. Okay, we could have a dash or colon, but it's not required to have a dash or colon. And 4 digits. Okay, so it seems like we want something to be followed by a dash and 4 digit. But remember, this pattern doesn't need to be followed. Like it could be 0 times, or this entire pattern should appear or should be matched 0 times or 1 times, right? So we definitely need 5 digits. And the second part of that is a dash plus 4 digits, or a colon plus 4 digits. We don't have any colon. And that could appear 0 or 4 times. And actually, this one is also a match. It starts with a dash. It has 4 digits, right? The problem with B is that Well, if you have a dash, then you definitely then you have to match another 4 digits at the end. So B is not a match here. Remember, this thing could either appear, you either have a dash plus 4 symbols or no dash plus 4 symbol or number, what I'm saying. So the answer for this one is actually A and D. Now, how about this one? Again, this entire pattern need to match this 2 digits, and then this is not an escape symbol. Notice that the direction of your slash matters. So 2 digits slash 2 digit slash 4 digit slash. So what is the answer? A. Great. Now let's move on to the next one. Okay, remember this, when it's appearing at the beginning, tells us, okay, your start has to match something, or you need to match the pattern from start to end. That's one thing. When it's appearing inside a pattern, like we use closed parentheses to specify a pattern, that means it's not. So we're picking something that's not starting with a space or at. It seems like we don't have something starting with a space or at, and that's fine. So this first part is telling us something that doesn't start with space or at, plus an at, followed by an at. Okay, seems like we need an at. And again, something that doesn't start with a space or at. So that means we shouldn't have 2 at consecutively, and plus a dot, that's something, plus this pattern, plus whatever string. So what is the right one? We need something that doesn't start with space or at, followed by an at, something that doesn't start with space and at, followed by a period, and then something that doesn't start with at or space. A and B. I think this is correct. The problem with D is that it doesn't have a point, a period. That's the problem with the D. For this one, it's not optional. You need to have a period somewhere in the pattern. Okay. Now let's see this one. I think this is not included in the classroom's material, but this is included in Tom's material. So this /1 is telling regex to match the first pattern. Okay. And in this particular case, the first pattern is this one. So this entire string should be in the pattern of a something that's enclosed by this, something like HTML something. That should be a word. That should be any word. And the second part of that should not contain this thing. It should not contain any of this, like, what is that? I think it's a div or something. It shouldn't contain anything like this. And then it should also contain another slash and then match the first pattern. And the first pattern is this guy. Any word. So it's word, something that does not contain this. I will call it less than. And something that is less than and have a backslash, and then follow a word. Exactly same word as this one. So what is the answer? B, C, and D, correct? This one, the key here is to acknowledge that this /1 means that, okay, this thing has to equal to the first string that has to match the same pattern that the first one is pointing to. Okay. And then this B is telling this pattern to be, okay, it's kind of like the XOR and $, but for a specific word. It's telling us, okay, this pattern works within this boundary. So it's saying that, okay, this should be a alphanumeric, A to Z is actually the same as /W plus, and it should be followed by a empty space. And next, the one is saying, okay, it should match the first pattern again. The first pattern is a string. So we need a string, a space, and another string. Which one follows this pattern? A string, a space, another string. The problem with B is that we're only allowed to have one space. In this case, we are only allowed to have one space, and okay, A and D only have one space, right? But remember, this /1 does not mean we need to have a 1, a number. /1 means that we need to be matched to the first pattern. The first pattern is a string, right? Yes, the answer is actually C. This is why sometimes I always say regex is intimidating to look at when you haven't deciphered that. When you don't know what is this regex doing, chances are you're going to read it wrong, unless you're really experienced in that. That's why I would say try to find existing regex pattern if you could. So the right answer should be repeat, repeat. The first one is a word. This is the boundary. This is the boundary. So ignore them first. A string followed by a space and followed by the first pattern. The first pattern is a string. So string, space, string. String, space, string. Okay, let's see the next one. Now, notice that this $sign is not at the end, right? So it's followed by a slash. That means we actually want a $sign. Okay, so it's $sign plus a number, however many digits you want, and followed by something. This something contains a dot. If you want to use a dot, you need to escape it. /dot means, okay, I actually want a dot. And then /d means I want, /d2 means that, okay, I want a 2-digit number. So I want something to start with a $sign, has a digit, however many digits it may, whatever number it could be. It could be 1, 2, 3, 4, 5, 6, 7. It could be 1, 1, 1, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I didn't specify the number of digits. Any number of digits. And then it is followed by a dot and 2 digits. So, which of them is the right one? B and D. Correct. Notice that we have a question mark at the end. That means this last part is, this pattern is optional. So this is an optional pattern. That means, well, you could have like a float digit, a decimal point, but it's not necessary. Now let's see this one. From start to end, you need to fit into this pattern. So it starts with a plus sign. You either have a plus sign. Oh, sorry. You either have well, yes, this is a plus sign because it's backslash. You either have a plus sign or this, like, you either have a plus sign and 1 plus a space. Notice that this pattern is optional. And this pattern is optional. And then the next pattern, subpattern we have is, okay, a 3-digit, okay, something that is like +1 or something, that's optional, plus a 3-digit number. And then we have this pattern that says, what is it? A dash or a dot or a space, which is optional. You could have an optional dash, dot, or space, plus 3 digits, another optional dash, dot, slash, dash, dot, or space, plus a 4-digit. So it should be something like that, roughly. So an optional +1, or like colon 1, followed by, this is optional, followed by a 3-digit number, which is also optional, and plus followed by a dash, point, dash, period, or space, plus 3 digits. This is not optional, plus another optional dash, period, or space, and 4 digits. So anything that has something like this, something like this, A, B, and C, I believe that's the answer. And also, if you see slash number, that almost always does not refer to a number. So this /1 means that, okay, I need to match the first group, which is A to Z, any like alpha, like any character. This /2 means I need to match the second group, which is any character. So I need to have something that match character, another character, another character, another character, and another character. So which ones are the answers? Remember, this one is not referring to a 2. It's telling us, okay, you need to be matched to a number. In principle, in regex, you never match to a specific number. If you want to match to a specific number, you will need to use apply method in pandas. B and D. I believe this is the case. Let's see if we get all of them right. Okay, congratulations. We just finished Tom's regex challenge. There are a lot more about regex, and to be honest, there are still a lot of the patterns that regex cannot handle. For example, and regex is a little bit error prone. Like, I think this is later in this course, in this syllabus, you're going to do web scraping, where you're going to scrape the source HTML file. Let me show you something like this. You're going to, like, this is the source file for this document. In the later part of this Python 100 course, you're going to scrape some of the contents based on this HTML file. This is where regex could be a very, very useful tool, right? I mean, I don't really need to like by pattern matching. I could just eliminate a lot of this like unnecessary text. That is helpful, but there are always cases when your pattern matching will not work. What do? Well, some of the in the last couple of years, people have been using like large language model to actually process that. It's useful, but it's costly and it's very, very slow. I think I've tried like parsing 50 or 60 pages of HTML with like Gemini or something on my local laptop, and it took 1 hour. It's not the most ideal thing to work unless you have a really large machine and you have unlimited budget. Another way you could think about it is you could always do regex pattern matching before feeding your data into LLM. But yeah, regex is not going to disappear overnight just because of LLM. It's not yet disappearing. You're going to work with regex for another while, put it that way. So hopefully, do they use regex for password cracking? Yes, they do. In fact, regex is used to, okay, this is to like, if you have seen those like, okay, create a new password or account number, and you say, okay, your password does not meet a requirement, chances are, yes, it's regex working behind the hook. And there is another problem called SQL injection, which means that, okay, if I do not do any restriction on my password or account number, for example, I'm trying to create an account number called select star from DB. In some like older like or terribly written web application, I could actually like inject my source code into their code bases by manipulating my like password or account number. That is a possible thing. It's usually a little bit more complicated than this because you need to know their like the name of their database to actually do this. But yes, it caused some problem. You could Google like SQL injection. You will see a bunch of things like that. So usually most of the modern web framework well, it's not built in. You actually need to write this yourself. You need to like write a function to check, okay, this is a valid password. It's not going to inject a piece of JavaScript code or like SQL code into your code bases and trigger some like malware somewhere. And that is one major application of regex. The other one in our context is like data cleaning. You could use regex to perform a lot of the data cleaning tasks like this, but most of the time is a lot of manual work. So I think this is actually the assignment for this week. So hopefully that answers the question. Okay, that being said, personally, I don't think regex is a very fun thing to work with, unfortunately. That being said, we have a more interesting part to work with today, which is about feature engineering and outlier detection. So let's move on to the more interesting part. Unfortunately, I don't think there's a good like way to systematically study regex other than just trying to write an exercise yourself. So hopefully you'll get through that. Regex is actually one of the most confusing stuff when I like, or more frustrating stuff when I started to learn programming. I still wouldn't say I'm really like great at regex to this date. Like I make mistakes with regex all the time. Okay, so today we're going to introduce another topic, feature engineering and outlier detection. So what exactly is feature engineering? So feature engineering is a part of the process where you're trying to like normalize your data set or create a new feature based on the existing feature so that your algorithm, whatever it might be, can extract more information. Some common example is, okay, if you trade stock, you have maybe like the daily price, the current price, and most likely your stock dashboard, let's say AAPL price dashboard. Let's see. Image. Other than the real-time price, you're going to see other lines, right? Sometimes it could be a 7-day moving average. Sometimes it could be a 30-day moving average. Sometimes it could be a 1-hour moving average price for whatever you want. And these are called the additional features. This is actually part of the feature engineering process. We are generating new information based on the data set so that we could use more information, or we could feed more information into our computer algorithm or for our own interpretation. Another common application of feature engineering is to transform data to normalize that. For those of you who, okay, how many of you have learned about linear regression, maybe in high school statistics or other area? A little bit. Okay, so linear regression is a method that's basically trying to predict. If I want to predict what's the price for the next hour, I could use, let's say, I noticed that there's a strong positive correlation between the hour I spent studying and the grade I have, or maybe there's multiple different features, like maybe it's a combination of the grade, my mental health, my how sunny or how difficult the exam is or whatever. You can quantify those metrics. Then you could build numeric models to do that. The problem is a lot of those models are sensitive to scale. For example, my test score may be, let's say, the hour of my study may be in the range of 0 to 10. But the other factors, for example, my blood pressure, if I had, or my blood glucose level, if I did not eat anything, my glucose level is low, I can't concentrate on the exam. It's just a dumb example. If my glucose level is low, maybe in the range of 50 to 150, hold on. The glucose level is always going to be more significant factors because it's on the range of 50 to 150. And my hour of study is only on the range of 5 to 10. When I'm feeding both of them in with their original numeric values, I'm going to have a hugely biased model just because, well, whatever I fit in has a larger number, then it has more significance in my model just because the number are larger. So a lot of the time, I don't want to feed them my original numeric value. That's why we might need to transform them into z-score or t-score. Another way to think about it is, okay, we all have high school GPA, right? I mean, a high school GPA, for a high school GPA, if one school is using a score range of 1 to 4, the other school is using the score range of 0 to 99. How can I compare them meaningfully? I want a way to compare them meaningfully. That's when I might use z-score, t-score, or their percentile score to make the meaningful comparison. And the same thing goes for computer. If I want to compare two numeric values side by side, I'd better transform them into something that's more uniform. Percentile score, z-score, t-score are the common ones. And similarly, I might want to encode categorical variable to numeric data types. What does that mean? Well, for computer, male or female is not a good thing to work with. But if I can convert them into, okay, male is 1, female is 0, I could use this categorical variable with other numeric variables I have, right? Now I can visualize them or I can run some other algorithms. So a lot of these transformation or feature engineering is really trying to make sure computer can understand that. Computer does not understand string. Like you may say, hey, but what is ChatGPT doing? Well, a lot of what ChatGPT is doing is actually feature engineering. What's under the hook is that OpenAI or whatever cloud platform you're going to use, they are converting your string input string into vectors. So there's different mechanism, different ways you can encode whatever I say, like I love you, or welcome to the class, or I love cat, into a piece like a matrix of number. And once what the computer actually observe is this number. And what's come out of those computer models are also similarly transformed number. And we have another algorithm to transform them back into human language. That's what's working behind the hook. Everything is number for computer. So feature engineering is really different ways to convert your data from strings or whatever you have, from images maybe, into numbers that the computer can read. So here we have a small, this one is actually a little bit larger than expected. We have a medium-sized data set. It's medium-sized because, okay, will be moved to future. It's going to take a while. Okay, finally loading. We have how many? 2 million? 2 million data points. I think this one is a little bit too large. But, well, 200,000 or 2 million, whatever. Actually, 2 million data points for this one. And we have, okay, employee ID, full name, their department, their job title, their hire date, their location, their performance rating, their experience in number of years, their status, are they resigned, are they active, retired, are they on site, hybrid, remote, whatever. And the first thing we're going to do is to use this as what we call the label encoder. We're not going into detail like what does that mean, but basically it's doing exactly what I say. It's going to convert, okay, like IT is now label 2, marketing is now label 3, and HR is now label 1. Now it's become a number. So I can visualize that. And performance rating, years of experience, status, and work mode is all converted into numbers. So this is one way to do feature engineering. And I'd say another part of that later. So why do we want to do feature engineering? Well, because once we have feature engineering and converting everything into numeric variables, we have more different methods to perform outlier detection. So there are plenty of ways to do outlier detection. The easiest way is by statistical model by box plot and IQR. In case you don't know what is that, box plot is something that looks like this. It's going to tell you, okay, this lower part of the box is your 25 percentile score, the thing you see in your df.describe. This is the 25 percentile score here. I'm plotting experience here, so that's exactly 2, right? And this is the median, which is the 50 percentile score. And this is the 75 percentile score at 8. This is the box plot. And from the box plot, we could detect if we have outliers with traditional statistical method. In this case, it seems like we do not have any outliers with this statistical method, because statistically, it's Q1, which is your 25 percentile score, minus 1.5 IQR. We should add what is IQR. IQR is your Q3 minus Q1, which is your 75 percentile score minus your 25 percentile score. And the data that's outside of Q1 minus 1.5 IQR, smaller than this value or greater than this value, will be considered outliers. Okay, this method only works when your data is not significantly skewed. What does that mean? Well, if your data is something like 0 and then a lot of, let's see if I have other more skewed data. Let's see this one. Okay, this one is telling us all of these things are outliers because my data is kind of skewed. Question: is it a good thing to just eliminate all this data? Should I? They're outliers. Can I just eliminate all of them? Should I? Statistically speaking, they're all outliers, right? Can I just eliminate all of them? Should be an investigation first. Correct. Like, just because it's statistically speaking an outlier doesn't mean we should ignore all of them, right? And also, this is like the kind of like basic rule for outlier. This just means, okay, you have some data that's deviating from the normal part. But I mean, let's put it this way. Einstein is a genius. His IQ is an outlier. Do I just eliminate Einstein's research because he's too smart? We can understand him. No, we should keep those data. And similarly, in a lot of cases, like maybe those outliers are what we're interested in. So it really depends if whether or not you want to eliminate the outliers really depends on what you want to do. Maybe sometimes you're just interested in those outliers. And also, this IQR stuff is the most common way to detect outliers, but it's not the only way. Well, it's the easiest way. It doesn't mean it's the best way. You could run the chi-square test, try to plot the QQ plot, etc., to see if you can detect the outliers. There are like a dozen or hundreds of different ways to detect outliers. You could get a PhD in outlier detection, trust me. So we're not going into details for that, but you could try to find the outliers those ways. And today we're going to do a lot of those things. So today we're going to introduce, there are some common like machine learning algorithms that you could also use to detect outliers. Common ones are k-means and dbScan. Today we're going to run a demo of dbScan. You do not need to understand like 100% what's going on. I'll try to give you a high level overview of that. This is how data scientists or data analysts might detect outliers in real life. Okay, so what are some better ways to detect outliers? The first one we're going to do is dbScan. So dbScan is a method that's, let me just jump to the results. dbScan is an algorithm that is going to basically put the items in within the same distance into the same clusters. Kind of similar to k-means, but it's unsupervised, if you know what I mean. So basically, it's going to say, okay, this one has a close neighbor. This one, they're all kind of close. Their distance is within a specific range. So they're all into this blue cluster. And these green ones, they're close enough together. So they're now in the same cluster. And there are a couple ones that doesn't quite fit into any of the clusters. They seem to deviate from majority of the data. And these are what we call the outliers. The exact mechanism for this algorithm is a little bit more convoluted than that. You need to scan through like each of the points and find like different distance. You need to use the distance matrix. You need to define like what is the minimum size of your cluster, etc., etc. We're not going into details for that, but this is one way you could do it. Okay, so, and in order to do this distance, like this dbScan to detect the outliers, well, we actually kind of need to do a lot of the feature engineering. So this is from the iris dataset we have used before. So here we're loading the iris data sets and we're scaling. I believe the standard scaler will just normalize the data sets. So the standard scaler is going to perform scaling, basically scale all of my data to the same thing so that I don't have a problem. Okay, one of the column is in the range of 1 to 10. The other column is in the range of 1 to 100. How can I compare them fairly? Well, with standard scaler, it will do it automatically for us. You do not need to know the details for this unless you're preparing for an interview. Maybe. It's not that complicated. I would actually encourage you to read through the documentation from sklearn. But here, we're trying to find, okay, what's the right distance what's the right distance for dbScan? This is called the elbow method. We think the best distance is when like this k distance graph is kind of flattened. Here, for this specific case, it's about 0.8, 0.9. So we use 0.9 as set up the dbScan. Running the algorithm is actually pretty easy. The implementation of the algorithm is complicated, but the algorithm itself, if you only run it with the API, is actually pretty easy. So ultimately we have decided, okay, these things seem to fit into the same cluster. The other guys seem to fit into the yellow cluster. These 4 points seems to be outliers. We may want to just ignore them for now or investigate further. Okay, and also notice that you could try to run a similar algorithm for this HR dataset. It might take you 20 minutes or something, just because the dataset is large, if you could still finish that. I think it's taking too long, so I'm not going to do that. Hopefully this shows you some different ways you can detect outliers. You could do like box plot, that's the easiest one. You could also define like your own criteria. For example, you think, okay, anything beyond a specific number is an outlier. I know enough about the data set. Like, I can guarantee that something like the minimums is, I don't know, 30,000. 30,000 is definitely too low. It has to be an outlier. The highest possible value is 3 million. It's way too high. It's definitely an outlier. You could just set up whatever algorithm and filter those data. We already know how to filter those data, right? I mean, I could just define like df of is equal to df of df the celery INR that is smaller than df of celery INR dot, let's say, q cut. This is going to cut like the 10 percentile or whatsoever. Or between that, something like that, you could filter the outliers with the data transformation method we talked about. But how do you know if something is an outlier? We don't really have like a perfect rule for that. That's usually where you need to investigate into the data yourself and know what the data is doing. We have various different methods that could help us, but yeah, there's no like universal best way to do it. Okay. Hopefully you find this helpful and interesting. And I think that's all I want to cover for today's session. Feel free to let me know if you have any questions from the assignments, from about this week's materials, or anything in general about Python. I'll hang here for a few more minutes, and yeah, I think that's all for this week. I'll hang here for a few more minutes to see if you guys have any questions.